All right, welcome. Today, we're cutting through all the hype. We're going to go deep inside the corporate world to tackle a really huge challenge. How do you take a super powerful internet-born AI and lock it down inside a high-stakes, super secure enterprise fortress? Let's jump right in.
So let me ask you something right off the bat, just to frame this whole conversation. What could possibly be harder than building a truly powerful next-generation artificial intelligence?
The answer? Trying to put that AI inside a bank or an insurance company or really any major corporation, because that right there is where the real fight begins. It's where all that theoretical power smacks right into the unforgiving reality of enterprise rules.
And that gets us to the heart of the enterprise AI dilemma. You see, it's a totally different ballgame than what we all see out in public. The conversation is not about how creative or smart the model is.
This slide just nails the difference. It's like two different worlds. Out in public, everyone's asking how powerful is the model, but inside the enterprise, the questions are completely different. They're asking, can it be accessed securely? Can we control every single thing it does? Can we audit its every move? And, this is the big one, can we shut it down in a split second if something goes wrong? And let me tell you, these aren't just nice-to-haves, they're absolute deal breakers.
So how in the world do you even start to solve this? I mean, you can't just drop an AI onto the corporate network and cross your fingers. You need a blueprint, a real master plan. And that's exactly what we're going to look at next, a 5-layer map for building this digital fortress.
Okay, this layered approach is the bedrock for every single design choice you make. It all starts with access and identity, who gets in. Then comes network and connectivity. How do they get in? After that, you've got the platform layer, the AI runtime where the magic happens, and holding it all together is data and governance. The real question this whole thing answers is, if this AI goes haywire, where, at what layer can I pull the plug?
Now, this architecture is built on a classic idea in networking, splitting your traffic into two planes. First, you have the control plane. Think of this as the management office. It handles the APIs, the policies, the audit logs. This part might have some very limited managed access to the internet. But then you have the data plane. This is where the actual AI traffic lives. The prompts, the queries, all the sensitive data. And here's the golden rule, the one you write in stone. The data plane is always private. It never, ever touches the public internet. Period.
This brings us to what is probably the single most important architectural rule for enterprise AI. We're not just building a secure system here. We're building a digital fortress that has absolutely no public doors or windows. We call this the Zero Public Network.
Okay, so what does that actually mean? It means you have to play by the enterprise's super strict rules. Just look at this list. No public IPs. All traffic going out must pass through a proxy or a firewall. The DNS can only find internal addresses. Every single time someone accesses anything, it has to be logged. And you can't just SSH into a machine. You have to go through a secure jump host. And here's the thing. AI doesn't get a free pass on these rules. In fact, AI is pretty much the main reason these rules are so strict in the first place.
All right, let's really dig into the 3 main rules of this zero public game. Principle number 1, the data plane is always private. This means every time the model runs, every query to a vector database, every little chat between AI components, it all happens in a totally isolated private part of the network. This makes sure no sensitive data can ever leak out. No exceptions.
Principle number 2 is all about the front door. Ingress, that's the fancy word for how you get into the system, is not the public internet. The only way in is from inside the company's already secure network. So from internal apps, over the corporate VPN, or through special private connections. The front door to the AI is already inside the castle walls.
And principle number 3, well, this one might be the most important one for managing risk. Egress, that's traffic going out from the AI. It absolutely must be controllable and killable. Think about it. If an AI agent gets tricked by a malicious prompt, how do you stop it? You have to be able to control where it can go online, log every single request it makes, and, most importantly, have a big red button to just cut off its internet access instantly. For an enterprise AI, going online is a privilege, not a right.
So we've built the walls of our fortress. Now we need to talk about guarding the gates and controlling how data flows, both inside the fortress and for those few, highly approved trips to the outside world. Inside the fortress, we think about traffic in two directions. You've got east-west traffic, which is all internal, moving between the different AI parts. Inside, you're all about speed and keeping things separate. But the second something tries to get in or out, that's north-south traffic, whoa, the focus flips completely to security and auditing. Every single packet gets put under a microscope. And this obsession with control isn't just for AI traffic. It's for the engineers who build and maintain the system. They can't just log in. First, they have to authenticate with multi-factor authentication. Then, they connect to a secure system called a bastion host. Their entire session is recorded from start to finish. And their access only lasts for a short time and is limited only to the specific thing they need to fix. No direct SSHing in, no backdoors, absolutely forbidden.
Okay, so we've built our fortress, we've guarded the gates. But is it really secure? The only way to know for sure is to try and break in yourself. And this is where we have to start thinking like the enemy. It's a process called red teaming. The problem is, AI doesn't just have the same old security holes, it creates brand new ones. And this table, wow, it really shows you how the game has changed. Look at stuff like prompt abuse or GPU takeover. These are ways to attack a system that basically didn't exist before. We're now in a world where a cleverly worded sentence could literally become an attack on your infrastructure.
This brings us to a super critical defense mechanism, one that every single enterprise security officer is going to demand you have. What exactly is an AI kill switch when we're talking about the infrastructure? So here's the crucial thing. An AI kill switch isn't just about turning the server off. It's about having the power to surgically and instantly shut down specific functions, like the AI's ability to use its tools or its access to the internet, or even specific model endpoints. And this is key. You have to be able to do it with a policy change or a firewall rule, without having to take down and redeploy the entire platform. It's the emergency brake for the whole system. You know, all of this really leads to a huge shift in how we think about this job. When you're building AI for the enterprise, your role becomes less about being some kind of wizard conjuring up magical models, and a lot more about being the warden of a very secure, very complex facility. Because at the end of the day, the goal isn't just to get a model up and running. The real goal, the one that actually matters, is building a secure, auditable, and resilient system that can survive the intense scrutiny of the information security team. If you can't do that, then even the most powerful model in the world is completely useless to an enterprise. I'm going to leave you with this final thought, which just perfectly sums up what it means to build things in the real world. Architecture is not about ideal designs, but about what can pass InfoSec, operate reliably, and scale within cost and compliance boundaries. That right there is the true challenge, and honestly, the true art of building AI for the enterprise.